Hello and welcome to the product demonstration of the single quality solution. My name is Hendrik Fischer. I'm the product manager of the software product at the product company Synatec, and I would like to spend the next few minutes to demonstrate the error-proofing capabilities of our software product to you. Before we get into the action, let me give you a brief introduction of the components of the solution that we have assembled here for you. At the top of this installation, you can see the HLT Industry Panel PC. This is a 19-inch version of the PC, and it's already running our SQS operator guidance. For this demonstration, we are also going to use a PowerFocus 6000 with two virtual stations, which each use a tool, of course. One of them uses a battery tool, the other one uses a cable tool. And we will be working on a little demo application that we have fixed to this table here. And it's going to require me to bolt two plates to the main demo plate. And I will have to do that in the correct order and use the correct plate on the correct side of the demo plate. Okay, with this, I would like to dive into the action here. And I'm going to go ahead and just pick up one of the tools here and try to use that, which I cannot because it is disabled. The software is locking the tool because there is no operator signed in at this point. It's very important for the data collection feature of the single quality solution, which enables traceability of the product, that we know who did the work. And in order to find out who the operator was that did the work, the operator, which is myself in this case, needs to identify himself. I'm going to use my badge for this on this badge reader and sign in. Now the system has changed. It now knows who is about to do work on the products. It'll be myself, and it's moved ahead to the login screen. The tools, however, are still locked. I can still not use them because there is no product signed in. Second part of traceability, of course, or most important part of traceability almost, is to understand and to know what product certain tasks were done on, and that means I have to identify the product before I can start any of the work. We have set up a product identification on this system here. It's going to require me to scan two product identifiers, or let's say two strings for identification. The first one is going to be the product identifier, or VIN. And the second one will identify the product variant that I'm going to assemble. Remember that I have two choices on this application. I can either bolt from or work from left to right or from right to left, and I have to make this identification before the actual work can start. As a first step, I'm going to take a sample product ID, which we have printed on this piece of paper here, and I'm going to scan this. And as you can see by the green line that is now on top of the screen, I have successfully identified the product. I still cannot start the work because I'm required to do a second scan and to identify which of the two product variants I would like to assemble. I'm going to pick the one that goes from right to left. That is process number 2. It's on the plate here. I scan it, and now the actual operator guidance has started. As a first step, I have to verify that I'm using the correct part for my product assembly. Again, I have these two little plates that I need to fix to this main plate here, and they are pretty much the same. The only difference really between the two are the two little QR codes that are printed here on the plate, and I can use those to identify that I'm using the right plate. For demonstration purposes, I'm going to pretend that I cannot read plate number 1 or plate number 2 and accidentally scan the wrong identifier for my plate. The system signals me now that I'm not using the correct part for the assembly that I'm supposed to do, and it will not continue at this point. It will not go ahead and enable any of the tools for me. They're still locked at this point. But I can correct my mistake, pick up the right part, scan it. Now it knows that I have the right plate in my hand. It marked it as green, and it lets me continue with the assembly process. I have to put this plate in place, seat my bolts. 1, 2, 3, 4. I will try to use the cable tool first. That's still locked. It is disabled. because I am supposed to use the battery tool for this task. And this one is running. So I'm going to just use this tool to fix the bolts in place. Oh, I did an NOK there, which is not good. I don't want to do, I'm not supposed to do NOK tightenings, but the system lets me continue to work on other tightenings that I can still do, and we will have to take care of this NOK bolt at a later stage before we can release the product from the station. But for now, I'm going to continue with the next one as indicated by the blue circle on the screen. Down, run it, marked OK. And the last one, also OK. So despite this one not OK bolt, I can continue my work for now and work on the remaining parts of this demo assembly. Put it down. Now the next step for me is to take the remaining plate and identify that again to verify that I'm using the correct part. It's not very difficult right now because I only have one plate left. I still need to scan it. It's the right one. I put it on the demo application, put my bolts in place, like so. Now, battery tool is disabled because for this one, I'm supposed to use the cable tool. So this one is now enabled. Down, torque it, go to the next one, torque that OK too. Some of you may be wondering how the system knows which of the bolts I'm actually working on. The answer is it doesn't really know, because without a position recognition system or a tool location system, there is no way to really know. We have to assume at this point that the operator is doing the bolts in the right order as indicated on the screen, but without any of these two systems, there's no way for us really to verify. So I'm going to continue. 1, 2, 3, 4. And that takes me to the end of the assembly routine. Now, this tool is locked again. I'm going to put this back. I'm now at the end of the assembly process, but I still have one NOK tightening to worry about before I can release the product from the station. That's the one that I did on plate number 1. And with this situation, with this NOK bolt, I cannot sign out the product and move on to the next product. I need to fix this somehow first. I, as an operator, do not have sufficient privileges in order to fix the situation myself. I cannot mark this bolt as OK manually or reset it so I can redo it. Instead, I need the help of my supervisor in this situation. So Victoria is going to step in as my supervisor. She will sign into the station using her badge, and then she's going to reset the bolt for me so I can fix the situation myself. There was the reset. Thank you, Victoria. And before I continue, I'm going to take my badge, sign in as myself, pick up the battery tool that was used for this. It's now enabled again, so I can fix the situation. First, of course, I have to loosen the bolt, like so, and then run it down, and that completed the work on this product. It is now fully okay. It has been signed out from the station. I can move on and work on the next product. Now that we have completed the assembly routine, and at the end of this demonstration, I would like that we pay a closer look to the data that was collected as part of the assembly routine, which means we're going to find out how traceability in an SQS works today. I have now opened the result data of our demonstration assembly in Microsoft Excel. So these are all the part scans and tightenings that I did during the demonstration. We have two types of data in here. There's bolt data, these are all the torques, and there's part data, which is the information that was gathered when I scanned the plates, either correctly or incorrectly. At the beginning of the process, as you can see, all the different operations, all the different tasks that I was supposed to do were marked with NYD, which is short for not yet done, meaning they haven't been completed. And then as I go through the lines of the assembly process, I can see how all of the different tasks identified by their unique ID and by their name start to change to either NOK or OK. Remember that I did an incorrect scan at first when I scanned the first plate. Instead of scanning plate 2, I scanned plate number 1, which is right here. That was, of course, not okay. And then I corrected my mistake by scanning plate number 2, which ultimately also set this task to okay. And then I did an NOK tightening on the plate number 2, on the right-hand plate, which I did, which is right here. I carried on with all the other operations, and then at the end of the process, I had to call Victoria as my supervisor to help me out here. And what she did was she reset this not okay tightening, and that resulted here in our recorded data, again, in a not yet done for this particular tightening, which I myself fixed then at the end of the demonstration, and it is now okay. Well, we're at the end of the demonstration. Thank you very much for watching this video. I hope it was useful to you. And I hope you can apply some of the things that you have learned today to your daily job. So thank you very much and goodbye.